Okay, now let's talk a little bit about buses and expansion slots. Now, buses used on motherboards include conventional PCI, PCIe, PCI Express, and AGP. Now, AGP is used solely for video cards. And PCI Express has been revised 3 times and is replacing primarily all other bus types. Now, when we talk about conventional PCI, it obviously we had to have a starting place, but then it has improved several different times. You have 4 types of slots and 6 possible PCI card configurations. And if you look up some of these, you'll see like even within the PCIs that a first gen PCI might have a notch near the end of it, just a little ways in, whereas another one might have multiple notches. So a universal PCI card can use either a 3.3 volt or 5 volt slot and can contain either of those notch configurations. Take a look here to kind of see that complexity of having, we have 4 different types of slots up here. You see where the rear end of the slot is, it would be located there. And then we have the 6 different possibilities down here based on if it's a 32-bit PCI card or 64-bit. And you can see we have different notch configurations that can work. So there's just a complexity of these, and you will be able to easily identify these. But with the PCI version 2.x here, you can see that there are 4 possible types of expansion slots and 6 differently configured PCI expansion cards that can use those 4 slots. So, and you'll see this with other expansion slots as well. Just be careful to make sure that you're identifying the expansion slot. Check the motherboard and make sure it is usually identified on the motherboard as to what type of slot it is, so that when you're buying, an expansion card that will fit into these slots, make sure you're matching them up correctly so you're not having to return products to get the one that you actually needed for that available slot. Now these PCI here, these are going to use a 32-bit or 64-bit parallel bus. Now when we move into PCI Express, this is going to use a serial bus, which is much faster than the parallel bus because it transmits data in packets similar to how your Ethernet network works or USB works. So we'll take a look at those here next. You can see those listed here in this diagram. We have a conventional PCI slot here in the very middle, that really long white one. And then we also have some new ones, some PCIe, PCI Express. Those are listed here. You have some PCIe times 16, times 4, and times 1 slots available here. Now the PCI expansion slot can provide 1 or more of these serial lanes that I was just talking about. PCIe or PCI Express slots, those are not backwards compatible with PCI or PCIe, as you can clearly see here on this motherboard. These are kind of expected to replace those PCI and PCX because they're just not really used much anymore. Now the PCI Express does come in 4 different slot sizes. You have the PCI Express times 1, as you can see is indicated here on this chart, the real small one there. We have 2 of those on this particular motherboard. We have PCI Express times 4 or X4. You can see that located on the left there, kind of a mid-grade one there, kind of medium between the PCIe times 1 and the times 16. And then the times 16, you can see that on this particular motherboard we have 2 of those PCIe times 16 as well. Now one of the latest versions is the PCIe 3.0. Now this kind of doubles the throughput of the previous version of 2.0, so just kind of keep that in mind, and I'm sure we'll have future expansions on these as we progress in technology, which could have just happened in the minute I've been talking. Now sometimes you're working in a system and you want to install something, but there is already something in a PCI slot so you can't really put the other one in. So what we have is a PCI riser card. So let's say we are installing like a micro ATX motherboard into a low profile case, and we just don't have enough room to install a PCI card standing up in an expansion slot. So we use one of these PCI riser cards to help solve this problem. And this just installs in a slot and provides another slot at a right angle or 90-degree angle. So when we install that, the card is then going to sit parallel to the motherboard, hence taking up less space to allow us to use those smaller form factor motherboards. Now, I mentioned this in a previous lecture, but there are some components that can be built into the motherboard, in which case these are called the onboard components. Those other components that are attached to the system in another way, those are like an expansion card. We'll take a look at those here. We have ports that are coming off the motherboard, which we've identified previously as like USBs, your sound ports, eSATA ports. You might even have those PS2, to support your mouse and keyboard ports. Now, based on the form factor that you select for your case, and when you're getting your motherboard to install, it will come, when you purchase it, with an I/O shield. And this is that plate that you install in the computer case itself that provides the holes for these input-output ports off the motherboard. A motherboard might also have several internal connectors, including like a parallel ATA or PATA, which we also call IDE connectors, if you remember that. You might have a floppy drive connector, some SCSI connectors. When you purchase a motherboard, look in the package for the motherboard manual, or see if possibly they have a CD that's included or DVD, so that you can have that diagram of the board with the description of each of the connectors. Alright, now let's move into talking about configuring a motherboard. Now, settings on the motherboard are used to enable or disable a connector port, set the frequency of the CPU or the front side bus, control security features, and control what happens when the PC first boots. Now, in the past, this was done in 3 different ways, using jumpers, setting that are stored in the CMOS RAM, and for really, really old ones, we use these dip switches. Probably won't see too many of those around. The more convenient way, more modern way that we do this is to store the configuration data in the CMOS RAM. And in today's computers, almost all have that configuration data there. When I say CMOS, that acronym stands for Complementary Metal Oxide Semiconductor. Now, CMOS RAM is a small amount of memory stored on the motherboard used to hold motherboard settings. Now, this CMOS RAM, it's going to retain the data even when the computer is turned off because it's being charged by a nearby battery. If you've ever looked at a motherboard, you've probably noticed that CMOS battery there. It's just looks like almost like a small dime or a metal coin. This is typically you're going to see the old CR2032 as a standard CMOS battery. You'll know if this goes bad if you turn on your computer and you see that the date on your computer is set to a really old date. You see here we're talking about, for today's motherboards, the program called BIOS, or Basic Input-Output System, is used to set up and make changes here in this CMOS RAM. Now, the BIOS, it identifies, tests, and initializes components and boots to the hard drive. The CMOS is going to store time, the date. As I mentioned earlier, if you see that you turn on your computer and that date's really old, that's a good indication that your CMOS battery is probably bad or going bad. And so you know it's a CMOS issue. The BIOS also can store and configure passwords and power management, as well as some monitoring. Now, to update your BIOS, you're going to flash it with new firmware. So make sure you're checking your manufacturer's website once in a while to see if there is a more current BIOS available in which you're going to flash that BIOS to install those updates that are needed for your computer.